Here's a question that sounds almost too obvious to bother asking, until you actually sit with it. Why do humans cook? No other animal on the planet does this. Lions eat their kills raw. Gorillas eat fruit straight off the branch. Dolphins have never once put together anything resembling a prepared meal. And yet, every human culture ever documented, every continent, every climate, every level of technology, from the most remote hunter-gatherer band to a modern city, cooks its food. Not some cultures. All of them. It's the one truly universal human behavior. Not language, which shifts wildly in structure from place to place. Not tool use, which plenty of other animals do in some form. Not religion, not music, not trade. Cooking, deliberately applying heat to food before eating it, is the one thing every human society on Earth has always done. And we've been doing it for so long that our bodies have become genuinely dependent on it, in a way no other species depends on any piece of technology it uses. That's the part most people never stop to consider, and it's what makes this whole story so much more than a historical curiosity. Cooking isn't just something we do because food tastes better afterward, although it dramatically does, and we'll get into why. We cook because, arguably, we can no longer survive without it. Over hundreds of thousands of years, evolutionary pressure has reshaped the human body into something built specifically around cooked food. Our jaws are weaker than a chimpanzee's. Our guts are shorter. Our teeth are smaller. Nearly every part of our digestive architecture diverges from our closest primate relatives in ways that point to one clear conclusion. Our bodies were rebuilt around processed, heated food. These aren't flaws. They're the physical fingerprint of a decision some ancestor made, so consequential that natural selection spent the next million years reorganizing the entire human body around it. And here's the strange part. We still don't fully know how it started. We don't know if that first act of cooking was intentional or accidental. We don't know the exact date it began. We don't know whether an early hominid pulled something out of a wildfire and discovered it tasted better, or deliberately sought out fire after some earlier accidental encounter, or arrived at the idea through something closer to trial and error. We're not even sure if the very first cooked meal involved meat or plants. What we do know is that somewhere, at some point, one of our ancestors tasted heated food for the first time, recognized it as better, and something in the trajectory of the species shifted permanently. To appreciate how big that shift was, it helps to look at what came before it. Roughly 2 million years ago, our lineage stood at a fork in the road. Our ancestor Australopithecus, upright, increasingly clever, living out on the African savanna, was still eating essentially the same diet a modern chimpanzee eats: raw fruit, tough raw roots, raw leaves, bark, shoots, the occasional insect or small animal caught opportunistically. That kind of diet demands an enormous amount of chewing. Modern chimpanzees spend close to half their waking hours doing nothing but chewing, not hunting, not socializing, not doing anything cognitively interesting, just mechanically grinding down raw plant matter so their bodies can extract a fraction of its calories. Chew, swallow, repeat, all day, every day. Harvard anthropologist Richard Wrangham actually tested this himself, spending time in Uganda, eating the same foods wild chimpanzees eat, just to understand the experience firsthand. His conclusion, delivered with typical scientific understatement, was that the food was simply bad. Tough, fibrous, bitter, and exhausting to chew for as long as it took to get anything usable down. He once spent 10 minutes on a single piece of wild fruit and came away with almost nothing to show for it. After enough of this, he became convinced of something important. A human being, with our comparatively small jaws and short intestines, could not survive on that diet. Wouldn't enjoy it. Could not physically extract enough calories from raw primate food to keep a human body running long term. That observation raised an obvious question. If our bodies genuinely can't handle what our distant ancestors ate, something must have changed along the way. Something that let our lineage pull dramatically more energy out of food, freed us from spending half our lives chewing, and drove the physical changes we see clearly in the fossil record. Wrangham's answer, which reportedly came to him while staring into his own fireplace in 1997, was cooking. Not meat eating, which other researchers had proposed as the great turning point. Not bigger brains driving smarter foraging. Cooking. He laid out the hypothesis in a 1999 paper and later expanded it in his 2009 book, Catching Fire. Cooking wasn't a nice cultural add-on that came along for the ride once humans got smart. Cooking was the engine that made us smart in the first place. We didn't evolve big brains and then figure out cooking. We stumbled into cooking, and as a direct biological consequence, our brains grew. The causal arrow runs backwards from what most people assume. To understand why, you have to look at what heat actually does to food on a molecular level, because it's a far bigger transformation than most people realize. And this is where the whole evolutionary argument really lives. Heat a starchy food, a potato, a grain, a root vegetable, and the starch granules inside absorb water and swell up in a process called gelatinization. Raw starch is tightly packed and crystalline, which makes it genuinely hard for digestive enzymes to break into. Cooking blows that structure open, and suddenly your gut can access far more of the calories locked inside. A raw potato is barely digestible. The same potato thoroughly cooked releases a much larger share of its energy to your body. Same object, dramatically more usable fuel, purely because it was heated. Heat does something just as important to protein. Raw meat is full of tough, connective tissue, collagen, elastin. That's genuinely difficult to break down, even with strong stomach acid. Heat unravels these proteins from their tightly wound structures into simpler forms your enzymes can attack far more efficiently. It also ruptures the cell walls in plant food, releasing nutrients that would otherwise stay locked behind cellulose. Your digestive system can't break through on its own. On top of that, cooking neutralizes many of the natural toxins and pathogens that plants evolved specifically to keep animals from eating them. In a very real biochemical sense, cooking is pre-digestion. You're doing a large chunk of the chemical breakdown work outside your body using fire as an external stomach, which means your actual digestive system has a much lighter job to do. The upshot is more usable calories from the same food, extracted with far less metabolic effort. Studies comparing raw and cooked versions of identical meals consistently show cooked food delivers more extractable energy. That's not a minor nutritional perk. In an environment where calories are scarce and competition for them is fierce, it can be the entire difference between thriving and barely scraping by. And then there's the time factor. Raw, fibrous plant food demands enormous amounts of chewing before it can even be swallowed. Cooked food is dramatically softer. Heat has already broken down the tough fibers, the connective tissue, the dense starch structures before the food ever reaches your mouth. Wrangham estimates that pre-cooking hominids may have spent close to half their waking hours chewing. Once cooking became routine, that dropped to something much closer to the hour or so modern humans typically spend eating each day. That's 4 or 5 extra hours reclaimed daily, for hundreds of thousands of years. Think about what that freed up time actually made possible. More effective, better planned hunting, more sophisticated toolmaking, stronger social bonds within and between groups, passing skills and knowledge down to younger generations, safer, more restful sleep, since fire also kept nocturnal predators at bay and let our ancestors sleep on the ground instead of in trees, exploring wider territory. Actually planning ahead instead of spending every spare moment on the immediate task of getting enough calories to survive the day. The campfire wasn't just a cooking tool. It was a security perimeter, a source of warmth that widened the range of livable habitats, a social hub that allowed sustained group interaction, and a time-liberating technology whose benefits compounded across generations. Now here's the part that should genuinely stop you. Look at what happened to the human body in the fossil record, right around when cooking is thought to have begun. About 1.8 million years ago, something abrupt shows up in the hominid lineage. Homo erectus appears, and compared to its predecessors, Australopithecus, Homo habilis. It looks like a different kind of creature entirely. A noticeably bigger brain relative to body size, a taller build better suited to sustained walking and running, and critically, smaller jaws, smaller teeth, and a shorter digestive tract. That last change, the shrinking gut, deserves special attention because it's one of the most striking transformations in the entire human fossil record. Chimpanzees and other primates carry an enormous digestive system relative to their body size, a large stomach, a long small intestine, and especially a big colon dedicated to slowly fermenting huge amounts of tough, fibrous, low-calorie raw plant material. That kind of gut is expensive. It needs a constant blood supply, generates heat, and demands a lot of food just to keep itself running. But if you're surviving on raw vegetation, you need it. In Homo erectus, that apparatus shrank substantially, especially the fermenting colon most relevant to processing raw fiber. In modern humans, that trend has gone even further. One researcher pointed out that while other primates carry a gut roughly 4 times heavier than their brain, in humans, the brain actually outweighs the gut. That's a striking reversal of biological priorities. Less gut, more brain. And that trade only works if the food entering that smaller gut is dramatically richer and easier to digest than what came before. In Wrangham's account, the timing lines up precisely with the shift to cooked food. Softer cooked food needs less jaw power and smaller teeth, so natural selection stopped favoring the massive chewing apparatus raw food primates need, and jaws and teeth shrank across generations. More digestible, more calorie-dense food means you can get by on a much smaller gut, so natural selection could downsize the digestive system without hurting survival. And the energy saved by maintaining less gut tissue got redirected to the single most metabolically expensive organ in the body, the brain, which was already expanding rapidly during this period, and today consumes roughly a fifth of the body's total energy, using about 9 times more energy per unit of tissue than most other organs. The brain is, in a word, extravagantly expensive to run, and it simply cannot be sustained without a rich, high-quality diet. Brazilian neuroscientist Susana Herculano Huzel actually ran the numbers. For a gorilla to grow a human-sized brain on its current raw food diet, it would need to spend an extra 2 hours a day eating. On top of the 8 or 9 hours, it already spends foraging and chewing. That pushes total feeding time to 10 or 11 hours a day, leaving almost no room for anything else and barely fitting inside the available daylight. The math simply doesn't work for a large-brained raw food primate. The only realistic path to a bigger brain is making food dramatically more efficient, and cooking did exactly that, decisively and permanently. The oldest confirmed physical evidence of controlled fire comes from Wonderwerk Cave in South Africa, where burned bone and ashed plant remains found deep enough inside the cave to rule out a natural wildfire date to roughly 1 million years ago. A separate find at Gesher Benot Ya'aqov in northern Israel, published in 2022, identified carefully heated freshwater fish remains dating to 780,000 years ago, the oldest direct evidence of actual cooking, as opposed to fire use in general. Those dates sit a bit awkwardly against Wrangham's hypothesis. If cooking really began with Homo erectus 1.8 million years ago, there's roughly 800,000 years of archaeological silence to explain. His answer, and one most archaeologists take seriously, is that small, short-lived campfires in open environments simply don't preserve well over that kind of timescale. The modest fires used by groups like the Hadza in Tanzania today would leave almost no detectable trace after 1 million years. Fire evidence survives best in caves and other sheltered spots where ash can build up in stable layers, so we should expect most of the early record to be missing. By around 400,000 years ago, though, the evidence becomes abundant and unambiguous. Hearths, burned animal bones, fire-cracked stones, and earth ovens turn up across sites in Europe, Africa, and the Middle East. By the time Neanderthals and early Homo sapiens were active, fire and cooking were clearly established, culturally transmitted survival knowledge passed down generation after generation. Exactly when it started is still debated. That it started, and that it changed everything, isn't in question. There's something genuinely unsettling in what all of this turned the human body into, and it's worth sitting with. Humans cannot survive on raw food, not in a mildly inconvenient sense, but in a measurable, biologically catastrophic sense. Studies of people who commit to fully raw, unheated diets as a lifestyle consistently find they can't maintain their body weight over time without leaning on modern technological workarounds. They burn more energy processing raw food than they gain from the nutrients it delivers, a caloric deficit that only gets worse over time. Up to half of women on strict raw food diets stop menstruating entirely, which is the body's emergency signal that it doesn't have enough energy to support reproduction. The body shuts down fertility before it shuts down anything else. From an evolutionary standpoint, a diet that halts reproduction in half your fertile population is about as fitness-destroying as a diet can get. A straight line toward extinction within a single generation. In effect, modern raw food communities are running a natural experiment that keeps confirming Wrangham's hypothesis. Our bodies, shaped by hundreds of thousands of years of cooked food, have simply lost the infrastructure needed to survive on raw food alone. The big fermenting colon is gone. The powerful jaw and wide molar surface are gone. The slow, patient raw fiber processing gut is gone. What replaced them? The shorter gut, smaller jaw, bigger brain, only functions as a working package if the food coming in has already been softened and broken down by heat. Chimpanzees can live on raw food because their bodies were built for it from the ground up. Humans were built for cooked food. Somewhere between 1 and 2 million years ago, our bodies crossed a threshold there was no evolutionary way back from, shedding the machinery we no longer needed, redirecting that energy into the brain, and locking ourselves permanently into a dietary strategy that requires technology to pull off. No fire, no edible food, no cooking, no survival. We are the only species in the history of life on Earth that genuinely cannot feed itself without a tool. Then there's the social side of cooking, which turns out to be almost as consequential as the biological one, and arguably even more interesting. Cooking produces a meal, a shared, prepared thing made at a specific time and place, eaten together. That's not a small social innovation. If your food needs to be cooked, you have to gather somewhere to cook it. You need fire, which someone has to maintain. You need people to guard whatever's being prepared from anyone who might try to take it. You need some kind of understanding about who contributes what and who gets what back. In Wrangham's telling, the campfire isn't just a cooking surface. It's the origin point of the household, the most fundamental unit of human social life. It's where having a dependable partner, someone who will protect your cooking while you're off gathering more ingredients and share the result with you and your children, starts to offer a real survival advantage over foraging alone. This leads to Wrangham's most provocative claim, that cooking may be the root of the division of labor between the sexes and even of human pair bonding itself. Not romantic love as we culturally understand it, but the practical arrangement of two people coordinating to gather and share food, anchored around a hearth, with children as the shared stake. In this reading, the household built around a cooking fire is the seed the most basic human social institution grew out of. And think about what happens once people are gathered around that fire in the evening. Bellies full from a cooked meal, safe from predators, kept at bay by the flame, with hours of non-chewing time still ahead before sleep. That's exactly the setting where language flourishes, where storytelling becomes useful, passing on where food was found, what dangers were spotted, which relationships need tending, where laughter, music, planning, and rehearsing future strategies all become possible, simply because you're not spending every waking hour either chewing or foraging for the next mouthful. The cooking fire didn't just feed the brain. It created the conditions for the brain to start doing the things that eventually made us recognizably human, reflecting on the past, planning for the future, passing accumulated knowledge down through generations. So the next time you're standing at a stove, turning on a burner, or lighting a grill, it's worth taking 1 second to appreciate what you're actually doing. You're taking part in the oldest, most consequential, most distinctly human technology our species has ever had. Older than agriculture by at least 1 million years. Older than any written language. Older than any religion, city, or government. Arguably older than language itself. You're doing something your ancestors were doing around modest fires on the African savanna more than 1 million years ago. An act that completely rewrote the trajectory of our lineage. Shrinking the jaw, shortening the gut, freeing up time, protecting the nights, organizing the social world, and freeing enough biological energy to build and sustain the very brain you're using right now to follow this thought. Every meal you cook is, in the deepest sense, a continuation of the act that made you human in the first place. A genuinely striking idea, even if you're standing in your kitchen at 11 p.m. staring at pasta stuck to the bottom of the pan. The principle holds either way.